Assalamualaikum warahmatullahi wabarakatuh. I am Muhammad Isa bin Yusri with the number metric AA 2009-34. One of the Group 4 Section 1's member will present about our solid mechanics group project, which the title is Bending Stress. As you can see, the following is the member of the group. The first is Muhammad Zulfakar bin Muhammad Rizal, me, Muhammad Isra, Habil bin Yusri, and the last, Martin Ling Teng Sang. So, our presentation begins by me discussing our first chapter, which is Introduction. Bending stress is the typical stress that an object experiences when it is subjected to a heavy load at a specific spot, causing it to bend and fatigue when operating industrial equipment, as well as when concrete and steel structures are subjected to a tensile force. Bending stress occurs. Bending, that also known as a fracture, is applied in mechanics is referred to the fracture formula. It is also explained that if load is created on a beam, so bending occurs is a fracture. Move to the next chapter, which is the theory. A beam deforms when it is subjected to a loading system or a force couple acting on a plane passing through the axis. Before we compute the bending stress, there are several assumptions that we need to make first. The following is the example. First, the beam begins with a straight portion and a constant cross-section. The second is the beam is formed of a homogeneous material and has a symmetrical longitudinal plane. Third, the resultant of the applied loads is in the symmetry plane. Fourth, the overall member's geometry is such that bending, rather than buckling, is the predominant cause of failure. Fifth, the elastic limit is never exceeded, and the elastic constant E is the same in tension and comparison. And seventh, plane cross-section before and after bending, the cross-section remain plane. If you look to the slide, it's shown as types of bending stress. There are two types of bending stress, which are first, pure bending stress and simple bending stress. For the pure bending stress, it can describe as when bending happens only due to coupling on end. It is referred to as pure bending. For the simple bending stress, when bending occurs due to beam self-load plus external load, it is referred to a simple bending. Types of bending stress. There are two types of bending strain, which are normal strain and transverse strain. For normal strain, it can also be described as the amount of heat that can be carried through a plate of unit thickness of a certain material, with the faces of the plate varied by 1 unit of temperature per unit time and per unit area. For the transverse strain, the ratio of the change in diameter of a circular bar of material to its diameter due to deformation in the longitudinal direction. That's all for me. I will pass the presentation to the next presenter.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Zulfakar bin Muhammad Rizal. My number matrix is AA200477. So I will continue the presentation in chapter 3, methodology. So how to calculate the bending stress? First, we need to do the moment diagram. Basically, the moment diagram can be used to we calculate the bending moment along the length of the beam. Next is the bending moment can then be used to determine the bending stress over the cross section of the beam at any point along its length. So the formula are stated in the slide. Next, we go to the bending stress is 0 at the neutral axis of the beam. So this is the coincident with the cross-section centroid. So basically the bending stress will grow linear away from the neutral axis, and then it reaching maximum value at the top and and the bottom of the beam extreme fiber. So we can see the tension at the top and the compression at the at below it. Next, we can calculate the using this formula. Basically, C is the cross section centroid distance. So the distance from the centroid to the extreme fiber. So the maximum stress will occur at the farthest place from the natural axis if the beam is asymmetric about the natural axis and the distance from the natural axis to the top and bottom of the beam are not equal. So this is the formula. So a cross-section modulus is made out of the centroidal moment of inertia I and the centroid distance C. So to compute the maximum bending stress in a cross-section, substitute the section modulus into the flexural formula. So this is the formula that come out from the formula above. So what is the real life application that we choose? The real life application that we choose are the skateboard, the bending from the skateboard when somebody stand on top of it. So how we calculate the bending stress in skateboard is first we need to identify the load that applies on the skateboard. So in this case, the load will be from the weight from the person. Next, we need to draw the free body diagram for skateboard. After that, we need to draw the moment diagram to calculate the bending moment. Next, we need to identify the location of the centroid and also the moment of inertia in the skateboard. So we can use the formula, the normal stress formula that stated in the slide. And lastly, we need to determine the compressive and also the tension area. So that's all from me. Thank you very much for listening.
Hello, my name is Martin. I would like to discuss about the analysis part of our projects. To calculate the maximum bending stress of our project, first of all, we need to analyze the condition first, which the load is represented by the human's weight of about 120 kg, and the dimension of the skateboard are 42 inch in length, 10 inch in wide, and also 0.5 inch in the thickness. And we can draw the free body diagram as shown in the step 2. Before starting the skateboard of calculation, we need to divide the mass of load into two parts and convert them into Newton by multiplying them with 9.81 Newton gravitational force. Next, convert all of the dimensions into meters by multiplying them with 2.54 times 10 to the power of negative 2 meters, and we can get 1.066 at meter length, 0.254 meter wide, and also 0.0127 meter in thick. By using the free body diagram, we can calculate the reaction force A and B by using the static formula that assumes that the sum of the moment of reaction force A in anti-clockwise direction is equal to 0. And we can get reaction force B is equal to 588.6 Newton as shown in the calculation. Next, we can calculate the reaction force A by assuming that all outward forces are equal to 0. And we can find out that the reaction force A is also equal to 588.6 Newton. And we can draw the shear and moment diagram from the calculation map, which is shown in the step 4. After drawing the shear force diagram, we can calculate the moment that is represented by the area of the shear force diagram, and finally we can get the moment is equal to 44.85 Newton meter, and the moment diagram is drawn. And from the moment diagram, we can conclude that the maximum moment is equal to 44.85 Newton meter. Next, draw the side view diagram as step C shown, and from the diagram, we can calculate the moment of inertia that I is equal to BD cubed divided by 12, and we can get I is equal to 4.336 times 10 to the power of negative 8 meters to the power of 4. And we can calculate that the maximum bending stress applied on the skateboard by using the formula maximum stress equals to MC divided by I, and we can get 6.568 megapascal. The last part is the conclusion. From the study, we know what bending stress is and also how to get or calculate the bending stress step by step with the help of some diagrams, such as free body diagram, shear and moment diagram, and also the side view of the application studied. Apart from that, we learn about the relationship between the bending moment and the bending stress, which when a bending moment is created, it will cause bending stress in the plane and cause the plane to bend. Bending stress is very important because if the bending stress is exists, it will cause the plane to break. Like the example of the real-life application that our group studied. If the bending stress exceeds the elastic limit, it will cause the skateboard to fatigue and break in the middle of it and cause the skateboarder to fall and might suffer from heavy injuries. So as an engineer, we need to calculate the bending stress truly so that we can choose a material that can sustain the bending stress and return to its original plane position after the load is removed so that the design application is safe and merit to be used. It's all from me, thank you.